Hello and welcome back to section 6.1 through 6.3. In this video we'll be going over example 2. Example 2 is going to help you learn how to identify zero force members so that you can simplify your trusses before applying techniques such as method of joints. So let's jump into that now. Alright, so here we have example 2. Now there are some dimensions, but they're not important for what we're about to do, so I didn't include them. So the goal of this is to find our zero force members. So if you remember on example 1, we had one member that was a zero force member. We were able to basically remove it as if it didn't exist. So that's our goal. If we can find zero force members, we can redraw this without those members. So when you start, what I would suggest is look at your joints that have no external forces. So at A we have an external force AX, at E we have these two, and at D we have this 3 kilonewtons. So these three are probably not good places to start. Also places with more than 2 members are probably not going to be good places to start, but it depends what it looks like. Look at the examples. I guess if the 2 are in a line, then that doesn't really count. So that might be an okay place if there's 3. So to start, we can look at B and C. They have no external forces, so they'd be a good place to start looking for zero force members. So if I draw B here, so again, I'm going to draw all of my internal forces as tensions. Well, if I look and say sum of forces in the X, I will have 1, 2, 3. So things kind of balance. If I look at sum of forces in the Y, I have 1, 2, 3. So far none of these appear to be zero force members. So let's go up here to C. Again, I'm just going to draw some internal forces as tension. So if I look at this, and if I do sum of forces in the X, I have both of these. But if I do sum of forces in the Y, only this one will show up. So you can imagine that I would have, say, force C here, and I would have a component of that, and then I would have the other component of that over here. And so if I did forces in the Y, I would find out that this component is 0. If this component is 0, then the whole thing is 0. So then we could redraw this circuit to look like this. With now, we have removed that one. So normally I won't redraw them. Normally what I would do is I would just put like an X through it and say it's zero force. So now we can go back, and again we have A, B, C, D, and E, and we still have all the same external forces, but I'm not going to redraw them right now. They still exist. So if I go back to C, now I only have this force. So if I apply forces in the X direction, this will now go away as well. So I will also have 0 here. So you can see immediately we have taken this thing, and we have simplified it down to the following. Again, you don't actually have to redraw this. I'm just doing it for this example so that you can kind of see what's happening as we remove these members, as we identify them as zero force. Alright, so now we simplify down to here. So I have A, B. So joint C, we don't even need that anymore. We have joint D and joint E, and I had a force here, I had a force here, I have a force here, and I have a force here. So now, if I look at B, again B doesn't have anything. I have up, left, and diagonal. So I have 2 things in the Y direction, I have 2 things in the X direction, so nothing here says that this is a zero force member. So now I'm going to go check the ones with the fewest forces. I'm going to go check A and D and see if we're okay there. So if I come up here to D, I might have a force coming this way and a force coming this way. Again, I'm just going to put stuff in tension. You can put stuff in compression if you want. So in the Y direction, I have this external force, this 3 kilonewtons right here, and I have this internal force. So they're both in the Y direction. So this one's probably fine. But if I look in this X direction, this is the only one that exists. So that means that this probably doesn't exist. Sorry, it doesn't exist. There is nothing over here to the right. It was this member for C that was keeping it in play, but now that we've established that that's not there, then this one goes away as well. So let's do the same thing at A before I redraw this again. So at A, And hopefully you can see that this member here, if I do sum of forces in the y, then I'm going to find out that there is nothing here. That has to be a zero force member. So let's redraw this again. And B. All right. Almost there. A, B, D, and E. All right. So we've established that this one and this one are gone. So all that's left is this, this, and this. So it's kind of like an arrow pointing down. So I have 3 kilonewtons. I have my reaction force here, so E in the Y and E in the X, and then I have a reaction force here, because this is a roller, A in the X, and then in here I will have some internal forces. Sorry, the pen doesn't like the highlighter. So at this point we don't have any more zero force members. Both things are in the same direction. So both things are in the Y, both things are in the X. I have 2 things in the Y and 2 things in the X. I have 2 things in the Y and 2 things in the X. So this is as simplified as we can make this system. So without doing any work at all, you can immediately tell that this is negative 3 kilonewtons in tension or 3 kilonewtons in compression, because you just do sum of forces in the Y right here. And so you would find this one. And then you could come down here to B, because you only have 2 things left to find. And so if you did sum of forces in Y, you'd find this one, and then you sum of forces in X, find that one, and you'd be done. All right. So that concludes our examples for 6.1 through 6.3. If you have any questions, feel free to jump into the Discord or to send me a message.